Welcome to video 9.3a, excuse me, Derive the altitude on hypotenuse theorems. There's a lot going on here, so if you want, you can take these notes and then I'll go through them with you after you got them copied down. One thing I want to point out is the altitude on the hypotenuse theorems work when you've got a right triangle and an altitude to the hypotenuse of that right triangle, and you will always get three similar triangles. In this picture, I'm calling them the left triangle, the right triangle, and the big triangle. And also what I've done is I've called this a leg of the big triangle, this a leg of the big triangle, and this is the whole of the big triangle. And this would be the altitude of the big triangle. And I've got these two parts of the whole. One more thing I've done, I've made up random angle numbers just to make it more concrete for my brain to understand. So I've got the right angles there, there, and there. I just magically made up 20 and 70, and once I made that up, ooh, this one must be 70 because they form a right angle. This one must be 20 because these two must be complementary, etc. So that's going to help me identify which triangles are similar to which in the correct order. So all I did is I wanted to see which triangles were similar. I went in the big triangle A, B, C, and angle-wise that was 70, 20, 90. So 70, 20, 90 is going to be my rule for everything. 70, 20, 90, 70, 20, 90, 70, 20, 90, 70, 20, 90, 70, 20, 90, 70, 20, 90. And then it's really easy to fill in the numbers. All right, so big triangle, A, B, C. For the left triangle, 20 is C, 70 is A, 90 is D. This is the most important part right here. The big triangle, again, 70, 20, 90, A, B, C. For this one on the right in blue, 70 C, 20 B, 90 D. And then over here is just a repeat. All right, so once I set those up, then I'm just using similarity. Okay? So what I'm trying to do is get the means to be the same. So I went AB is to AC, so first two letters and first over third is to first two letters and first over third. Over here, I went AB to BC, first two to last two, first two to last two. Over here I went AD over CD, first and last over last two, first and last over last two. Okay, so that's how I set up all my proportions. And then all I did is I cross multiplied. So AC squared equals AD by AB, BC squared equals BD by AB, and CD squared equals AD by BD. Then, there's no way you're going to remember this, but these boxes are the thing that you can remember. All right, so then I went to my triangle. Oh, AC is really a leg. So I'm going to remember this as leg squared equals AD is the near part, and AB is the whole part. So I'm just going to remember leg squared equals near times whole. Likewise over here. BC is a leg. So I said instead of BC squared, leg squared, BD is that near part, and again AB is the whole. So this works twice. Leg squared equals near times whole. All right, that's no problem. Over here I get something slightly differently. CD happens to be the altitude. So I'm going to call CD squared the altitude squared. Then I've got AD and BD. I'm just going to call that a part and a part. So to summarize, all you need to know as far as applying these is what the formulas are. Leg squared equals near times whole, and altitude squared equals part times part. And in theory, you don't even have to do these. You could do it all by similarity, but that would just take a little bit more time. These are just worked out shortcuts for similarity. And once again, it only works when you've got an altitude on a hypotenuse. So you've got to have a big right triangle divided by two smaller right triangles with the altitude. I'll do some more examples coming up next.